Tutor Level 3, welcome back. Today we're going to look at paper 91399, which is a demonstrate understanding of the efficiency of market equilibrium, otherwise known as allocative efficiency. So let's get into question 1. Question 1, increase in the world price. Graph 1 shows the world price increasing for products that New Zealand exports. Exports is key here. Before reading the question, we can see that there's a price here, PW, price increasing to PW1. And then we've got our export from QD to QS as we supply more than we demand, and therefore we export the difference, and then as the price rises we demand less as it's less affordable, and as the price rises to PW1 we supply more as it's more profitable. So let's have a look at the numbers here. So the price that New Zealand consumers pay, that's going to be PW before and then PW1 after. So PW before and PW1 after. The price New Zealand producers receive, again it's the same value, so it's PW before and then PW1 for after. The quantity consumed by consumers, that's the QD, or the quantity demanded at the world price. So QD1 is after at the higher price, and then QS is for suppliers supplying at the world price, and then QS1 after the change in the world price. If we go into the surpluses here, we can see that we need to the before world price and then after world price for consumer surplus, producer surplus, and deadweight loss. So before the world price change, the consumer surplus was A, and C over to PW was this green triangle here. Why is that? It's because this is the demand curve, this is the price we're willing to pay, and then this is the price that we actually pay, this PW. So the difference is the extra surplus gained on each unit consumed for all of the units up to QD. After the change, however, we move to this much smaller green triangle of A, B, PW1, and that's because now we're paying this higher price, so there's less surplus gained on each unit, and there's less units from which to gain a surplus. For producer surplus, before it's going to be PW down to F for the quantity, and then down to E. So it's going to be the supply curve, or the difference between the supply curve and the world price. And then after, it's going to increase to this larger amount, which is all the way up to G and all the way up to PW1 as they receive a higher price. Therefore, there's a greater difference between the price they're willing to receive and the price they actually receive, and more units from which they're going to gain a surplus. So producer surplus has increased. So the areas for that, let's look at them now down here. It's going to be A, C, PW for consumers, and then after it's going to be A, B, PW1, the new higher world price and the new higher quantity. For producer surplus, it's going to be PWFE, and then it's going to increase to PW1, GE. On my graph here, I can see that there was no deadweight loss before, and after, there's still no deadweight loss. So there was our consumer and producer surplus. There's no government intervention, so there's no deadweight loss. And then after, the consumer surplus obviously gets a bit smaller, but the producer surplus gets much larger. And again, there's surpluses are maximised. There's no deadweight loss in the market. It's still allocatively efficient. Explain why the world price is a horizontal line. But the world price is horizontal because New Zealand is a price taker, which means we must accept the world price. We're too small for our changes in supply and demand in our local market to influence the world price. Therefore, we must accept whatever the global market demand on market supply equilibrium is, and then that comes across onto our individual country graph as a horizontal line where we can identify the QD and the QS at that particular price. I'll refer to graph 1 and table 1 and table 2 in your answer and explain in detail the impacts of the increase in the world price on a product that New Zealand exports might have on the following: New Zealand consumers. So for this, we always need to talk about some similar things when we're talking about the impacts on producers and consumers. It's going to be, what price do they pay in the demand curve? So in this case, it's going to be the difference between the price that they were willing to pay and the price they actually pay has decreased. Therefore, there's less surplus gained on each unit consumed. So the price is part 1. The quantity. What's happening to the quantity of whatever the product is? And in this case, the quantity is decreasing, which means there's less units from which to gain a surplus. So there's firstly less surplus gained on each unit, and there's less units from which to gain a surplus. So then the overall, which is our third point, so it's price, quantity, overall. If there's a decrease in the consumer surplus per unit, and there's a decrease in the number of units, then overall, we're going to see a big decrease in the consumer surplus. And we've seen that on the graph as the green triangle got much smaller. In each case, we're going to refer to the graph. So we're going to say, well, as the price increases from PW to PW1, the difference between the price they're willing to pay and the price they actually pay decreases, etc. Same with quantity from QD to QD1. If we go to New Zealand producers, again, let's talk about the price. The price that they receive has increased from PW to PW1. What does that mean? It means that they're getting more surplus on each unit that they sell. Therefore, the price or the difference in price has increased, meaning there's more producer surplus on each unit. Then we talk about the quantity. They're selling more units because they've gone from QS to QS1, QS to QS1. So they're selling more units. Therefore, there's more units from which to gain a surplus. Overall, they've got an increase in the surplus per unit and an increase in the number of units. Overall, it's going to be a big increase in the producer surplus for those exporters. And finally, explain the impact of the increase in the world price on the market for a product that New Zealand exports on allocative efficiency. So, let's have a look at our graph. And this is going to be maybe a bit of a trickier one for some people. So the old surpluses were this area and this area. And the new surpluses are all of that plus all of this new producer surplus part here. So this area has changed from being was consumer, now it's producer. And this has increased. So we're allocating our resources more efficiently because we're getting more surplus. So there's no deadweight loss to talk about, but we can talk about the other things, which is that the total area of consumer plus producer surplus has increased allocative efficiency, and there's still no deadweight loss present. So the market is more allocatively efficient when the surpluses have increased and the surpluses are still maximised. Okay, so let's look at question 2, indirect tax. Half the price of a 12-pack of beer will soon be made up of tax after the government announced the second large beer tax policy in 30 years. Alcohol excise rates, which apply to domestically produced alcohol as well as duty on imported beer, wine and spirits, will increase by 6.6% on July 1st. The Brewers Association of New Zealand Executive Director Dylan Firth said the increase could not come at a worse time for brewers and consumers. There is more than one reason for increasing the tax on alcohol. One of them is to discourage consumption. Graph 2 shows the market for alcoholic drinks at equilibrium with equilibrium price PE and quantity QE. So then here's my graph. I've already drawn one line on it to get a head start for us. A $2 per drink indirect tax is imposed on the market for alcoholic drinks. Complete the graph by adding the new curve, identifying the new equilibrium and labelling a shortage or surplus. So our curve is going to go right here, which is 2 points above every point on the supply curve. And then we're going to label that curve by showing the new equilibrium price and quantity. And then obviously we're going to get the new producer price, which is the value that the consumers pay minus the value of the tax. And then we need to label the shortage as well, which is at PE. Where is our new supply curve, which is here, or QS, 22.5 million. And so that's QS. There's our shortage. There's our Q1 and P1 labelled. There's our PP labelled. And then the last thing we need to do is up here, just write S plus tax. Nice. So we've got our P1, PP. The difference is the value of the tax. So this is the $2 value of the tax. And then this is our shortage between these two values. So question 2 is explain how equilibrium would be restored in the market for alcoholic drinks following an increase in indirect tax. I'm just going to talk it through on the graph right now. I'm not going to type out the answer. So at the original price, quantity demanded equaled quantity supplied at PEQE, right here. Then there was a change in supply to the S plus tax curve. So supply or quantity supplied decreased to 22.5 million here at QS. However, demand remained over here at the QE mark. So that means QD was greater than QS. So there was greater demand than quantity demanded and quantity supplied at the original price of PE. Therefore, the we need to figure out who responds. In this case, the demand or the consumers are going to respond, as they're the ones that are missing out on the products. They're missing out on alcohol, so they're going to increase the price by bidding up the price in order to ensure that they access the shortage. As the price rises, the quantity demanded will fall as alcohol becomes more expensive or less affordable due to the law of demand, and at the same time, quantity supplied will rise up the supply curve as alcohol becomes more profitable, and therefore producers will increase their quantity supplied. This will continue until the new equilibrium price and quantity is reached at P1Q1. So that's our answer for this part 2. Part 3 is we need to figure out the changes in surplus. So if we look at our graph again, let me get rid of some of these extra labels, and we need to label the change in the surplus. So we know that the consumer surplus is above the price, which is there, and below the demand curve, which is there. Then the price has risen for consumers. I'm going to label this PC just to help me. So this P1 is also known as PC. The price has risen to $8, so now the consumer surplus is here. All of this is the same, but all of this is lost. So how do we including this triangle? So how do we calculate that loss? We need to take the difference between the two prices. So it was $6.50 to $8, so $1.50. And we need to times that by the number of units, so 45 million. And then that's one part, that's the rectangle. And then the triangle is going to be calculated by finding the difference, which is 7.5 times 1.5. And then we add those two units together. And the number we come out with in the end is 73.125 million. And that's a decrease. For producer surplus, or their surplus, is the difference between the price and the supply curve. And even when a tax is added, the supply curve remains the same. So the new price is $6, or 50 cents less. So this all remains the same. And then this rectangle plus this little triangle is the area lost. This rectangle plus this little triangle is the area lost. And again, we can work out in a similar way, which is 50 cents times 45 million, or 0.5 times 45, plus 0.5 times 7.5 over 2. And then we add those two values together, and we're going to get $24.375 million. The total tax revenue, we can calculate that by finding the area of the square of tax revenue. It's going to be the difference between the price for producers and the price for consumers, so that's this price, times the quantity of goods sold. So it's all of these, because each unit sold, 45 million units, times $2 per unit. So of course that bottom value there is going to be 90 million. And then the deadweight loss is this triangle right here between, and it's the area of surplus that's lost, which isn't transferred to government revenue. So it's too high, and then 7.5 across, so it's 2 times 7.5 divided by 2, so it would be 7.5, a nice and easy equation to finish, 7.5 million. And then both of these would be decreases. So then let's talk about the impact on consumer surplus, producer surplus, and allocative efficiency. And remember our formula or our structure, it's going to be what happens to the price, what happens to the quantity, and what happens overall. So the price increases for producers because of the tax. We increase the price from PE to P1. This means the difference between the price that they were willing to pay, let's have a look, the price that they were willing to pay, the demand curve, and the price that they actually pay, the supply curve. The price they were willing to pay, the demand curve, and the price they actually pay, PE, has decreased as the demand curve remains the same and we move to this new higher price. So less surplus on each unit consumed, and the quantity is decreased from QE to Q1, so there's less surplus because there's less units from which to gain a surplus. So overall, a decrease in consumer surplus. For the next one, consumer surplus, they were receiving a higher price, but that's now decreased to PP. So the price received by producers has decreased from PE to PP, decreasing the surplus gained on each unit sold. Therefore, less surplus. And the quantity is decreased From QE, 52.5 million to Q1, 45 million. So there's less surplus from which to gain, of less units from which to gain a surplus. Overall, there's a decrease in producer surplus by 24.375 million. Then the last part here is talking about allocative efficiency. And before, the market was at allocative efficiency. Supply was equal to demand, the surpluses were maximized, and the total area of producer and consumer surplus were maximized. However, now there is a deadweight loss present. Surpluses are not maximized, and therefore the market is no longer allocatively efficient. All right, let's get into question 3, maximum price and elasticity. So to help ease the impact of the cost of living crisis, the government could impose a maximum price on some grocery items. Graph 3 shows a maximum price control on an item with an inelastic demand, with the steep demand curve here, and graph 4 shows a maximum price on an item with elastic demand on the shallow curve here. And as you can see, the supply curve and the Pmax and the PE are all at the same points on both graphs. Complete the table by using the numbers in graph 3 and 4 to identify the surpluses and the deadweight loss. So let's have a look at this one I made earlier. So we've got our demand curve showing the price that we're willing to pay. We've got the PE showing the price that we actually pay. And then the difference between the two is my consumer surplus. And then on the other side is the supply curve, the price that they're willing to receive. PE, the price they actually receive. And then again, the difference between the two is our producer surplus. So that might look like this. So 1 and 2 for consumer surplus, and then 3, 4, 5 for producer surplus. Then for graph 4, it's very similar. 6 and 7 before, and then 8, 9, 10 before. So right now we're ignoring Pmax. Then when the change comes in, all of a sudden the producers are receiving a lower price, so they're going to have less surplus gained on each unit sold. And they're receiving a lower quantity, so they've got a lower surplus. So that means that they're losing surplus from the quantity and the price, and that's why they've decreased by area 3 and 4 to 5. Same on the other side, a lower price, so less surplus per unit, a lower quantity, so less units from which to gain a surplus. They've decreased their surplus. The consumers, they've gone from 1 and 2. Now they're receiving a fewer quantity, so less goods from which to gain a surplus, but on each good that they are still purchasing, they're getting a larger surplus, so it's 1 and 3, or 6 and 8. The deadweight loss, finally, is the area that was surplus before. However, with the maximum price implemented, not all of the surplus lost from consumer and producer is transferred to the consumer. So not all of this area lost by the consumer and producer surplus is transferred. Some of it goes missing or is lost, which is the deadweight loss. So area 2 and 4 on graph 3 and area 7 and 9 on graph 4. So let's have a look at what that looks like. Over here, it is 1 and 2, 6 and 7, 1 and 3, 6 and 8, 3, 4, 5 for before, 8, 9, 10 for before, 5 for after, 10 up here for after, and then 2 and 4, and 7 and 9 after. Then we have to do the next question, which is the written question. Define price elasticity of demand and explain one reason why an item might be elastic. So define is classic question here, and we should be able to define all the terms that we use. In this case, price elasticity of demand measures the extent of the change in quantity demanded of an item in response to a change in price. Another word you could use in there is responsiveness. So how responsive is a change in quantity demanded to a change in price? An item may be elastic if there's many substitutes because the consumer can easily swap to another good if the price increases, or if it's a luxury because the consumer can go without it if the price rises. This means that a change in price will result in a proportionally greater change in quantity demanded for an elastic good. So then we're going to compare and contrast the impact of the maximum price on consumers, producers, and allocative efficiency on graph 3 and 4. And we want to do a similar thing as we did in the last question, which is talk about the consumers, talk about producers, and then talk about allocative efficiency. So the consumers, the price they pay has decreased. So the surplus gained per unit. As we see here, the surplus gained per unit is increased at the lower price for both cases. To add to this, then we talk about quantity. Unfortunately, the quantity is decreased, so there's less units to gain a surplus. In both examples, the quantity is decreased, leaving less units from which to gain a surplus. Then we talk about overall. So for the consumers, they've lost 2 but they've gained 3, so overall they're better off as the area lost is smaller than the area gained. And then the same for on this side, the area lost of 7 is smaller than the area gained of 8, so they're better off. Producers have price quantity overall, so the price decrease has made them worse off, and the quantity decrease has made them worse off. So overall, they're worse off from graph 3 and graph 4. And then finally, before finally, it's the government, which in this case is not going to help us. So we're actually going to delete this one because we're not really talking about the government. It only asks about allocative efficiency. And then allocative efficiency, loss versus gain, sum of surpluses maximized because the difference between the willing and actual is greater. So let's have a look at that. So is this allocatively efficient? No, because the area lost, 2, 4, and 3, is not offset by the area gained, 3, leaving 2 and 4 lost, which means that the surpluses are not maximized, or the sum of the surpluses is not maximized. The market does contain a deadweight loss, and the market is not allocatively efficient. We can see on graph 2 that the area lost we can see on graph 3 that the area lost of 2 is greater than the area lost in 7 because the decrease in quantity, this is because the difference between the price they were willing to pay and the price they actually pay is greater on graph 2. So for each one of the quantities, or for this quantity, the difference lost is greater in graph 3 than it is in graph 4. And that is the end of the paper. Very exciting. Let me know if you've got any questions below or if you want another paper.